Good morning, everybody, and welcome to Ceramic Storytime with Sue. I am Sue McLeod, and I'm going to be reading to you one of my blog posts today. It's called How to Turn a Matte Glaze Glossy with One Ingredient. So I'm just going to give you guys a chance to join me here live, and then I'm just going to check that everything is working, because it doesn't always work the way I expect. So it looks like I'm live. Excellent. So if you are here with me live, then please say hello in the comment section under this video. And I'm just going to post a comment with a link. So if you want to interact with me and participate, ask me questions while I'm giving this presentation, then you're welcome to write your comments. If you click the little link that I posted just below this video, then that will allow me to see your name attached to your comment. Otherwise, it just says Facebook user. So if you want to do that, then that would be great. And let's see here. Okay, so I see there are a couple of people here. So if you're just joining, please say hello in the comment section. Let me know where you're joining me here from today. And again, I'm going to be reading my article, How to Turn a Matte Glaze Glossy with One Ingredient. So we're going to talk a little bit about chemistry today. So if you're new to glaze chemistry, it might be a little bit complicated, but I hope that I can explain it in a way that kind of makes sense for the beginners as well as the more advanced. And if you want to follow along, the link that's scrolling along the bottom, bit.ly/Matte Glaze Glossy, that'll get you to the blog post that I'm going to read. And so you can kind of follow along with me while I'm reading it. And so I'm just going to share my screen, and I'm going to hide this title here. So we have more of the screen to work with. And then, okay. So yeah, if you go to bit.ly/Matte Glaze Glossy, then that will bring you to this web page on my website, and then you can follow along. There is an opportunity to download this article as a PDF. If you'd like to keep it and save it for your files, then you just click this button here, and then enter your email address, and then I will send that to you. Okay, hello, Andrew from Nova Scotia, and Joan is here. Welcome. Awesome. So glad to have you here. Okay, so feel free to ask me questions as we go along, and I will pause and answer them. I did get an email question from Phyllis that I'm going to address later. And then quite a few people have asked me whether, so I'm going to explain how I took a matte glaze and then I added one ingredient to turn it into a glossy glaze. So people are always asking me whether you can turn a glossy glaze into a matte glaze and go the other way around. So I am going to explain how and when that might work. It wouldn't always work. It does depend on the chemistry. So I will show you kind of what to look for with your glaze recipes and see if your glossy glaze could possibly be turned into a matte glaze by removing this ingredient. So I'm going to get started. Just feel free to type in the chat as you please. Okay, so how to turn a matte glaze glossy with one ingredient. So in these photographs here, just to explain, so we've got on the left is the matte version, and then on the right is the glossy version of the same glaze plus the ingredient, which is silica. Spoiler alert. So this one is with the matte glaze made with cobalt, and then this one is with iron, and this one I believe is with manganese. And so we have a matte version and a glossy version of the same glaze, and the recipes are very similar to each other, except the glossy version just has added silica. So I'm going to explain how that works. I'll keep those pictures on the screen. Okay, a simple way to turn your matte glaze glossy. Do you have a matte glaze that you wish was a bit glossier? Would you like to make a glossy version of one of your matte glazes? It's really easy to convert a matte glaze to a glossy glaze just by adding one ingredient, silica. And the formula for silica is SiO2. It's silicon dioxide. So the 3 photos above are pairs of test tiles where the only difference between each pair is the addition of silica. Matte glaze on the left plus silica equals the glossy glaze on the right. Pretty cool, right? To get more specific, let's look at the recipes. So these are screenshots from glazy.org. So I've got this calcium matte base glaze here. So you can see that it all adds up to 100%. And then on the right here, you can see that the percentages of every material are exactly the same except for the silica. So here the silica is 11.5%. And then over here, I added 40% silica. So we've got 51.5%. So all the rest of the materials are the same. We just added 40% silica. So you can see that this one adds up to 140. This one adds up to 100. And I hope you can see my mouse. Yes, it looks like you can. So the first thing to look at is the percentages for each material. The weighting is the same, the NEFSI is the same, the EPK is the same, and the Frit is the same. But the silica has 40 more grams per 100 grams. So 40 more percent technically, although that's a bit weird to say, but 40 more grams per 100 grams in the glossy version than the matte version. That's literally the only change that was made to the matte glaze to make it glossy. So if I were to make 100 grams of this matte glaze and then add 40 grams of silica, I get a glossy glaze. And that's exactly what I did to create the test tiles at the top of this article. Pardon me. The next thing to notice is the recipe totals at the bottom. So these totals here. The matte glaze adds up to 100 and the glossy glaze adds up to 140. I could have normalized the glaze formula, the glossy version, so that it adds up to 100. So normalizing means you can take a glaze recipe that adds up to any percentage, and then you can normalize it so that it adds up to 100. So you keep all the proportions the same. You just change the values so that they then add up to 100, which makes all of the proportions percentages of 100. So I could have renormalized this, and then all of these numbers would have changed accordingly, but I left it the way it was so you could easily see that the only difference is silica. Let's see, but I left it this way to make the change obvious when I go back and look at it in the future. So now we're going to have a look at the chemistry. Okay, the following image shows the 2 glazes plotted on the Stahl chart, named after the scientist who developed it in 1912. So this down here is the Stahl chart. This chart takes the UMF, which is the unity molecular formula of a glaze recipe, and it plots the silica level on the x-axis and the alumina level on the y-axis. On the Stahl chart, the only variables are silica and alumina. Fluxes and boron remain constant throughout. So here is the Stahl chart. So I'm just going to scroll up a little bit. So we've got the molecules of silica. So once we take a glaze recipe, we convert it to the unity molecular formula. And that's what it breaks down a recipe into all of the molecules that make up that recipe. And so you've got your silica, your alumina, boron, all the fluxes like sodium, lithium, potassium, calcium, magnesium, zinc, barium, strontium. So those are like the main base ingredients for a glaze recipe. So you take a recipe, you can enter it into a some glaze software. I'm losing my brain, my way with words right now. So you can enter it into software that converts a recipe into the UMF. And so it tells you how many molecules of silica you have and how many molecules of alumina. So then you can plot those values on this chart here. And then the chart is kind of divided up into regions where these are patterns that Stahl found. So when he was doing his experimentation in 1912, he plotted glazes so he made a glaze recipe for all these points on this map, and then he realized that all the matte glazes fell in this green section. Semi-matte, so like the satin glazes, are in the middle here. And then this pink section is where all the glossy glazes fell. And then we've got underfired, devitrified in the turquoise sections on the outside. So he noticed that based on the relationship between silica and alumina, and based on the levels, that you have these patterns for where a matte glaze and a glossy glaze would fall on the chart. And so what it does is it creates a way where you can kind of plot your glaze recipe on the Stahl chart and then predict whether it's going to be matte or glossy. And so it works pretty well. And I have actually I've made this chart where I made a glaze for each point on the chart as well, and fired them to cone 6. So Stahl was working at cone 11. So I recreated this chart at cone 6 a couple of times, and it does work the way that he predicts. There are some factors that come into play that are going to affect whether everything kind of matches nicely, but for the most part, this is how it works. So I'll get back to reading. Okay, I have color-coded the regions of the chart to make it easier to see the patterns. The green region is where the matte glazes are found. The pink region is where the glossy glazes are found. The yellow region is somewhere between matte and glossy. And then the turquoise regions are generally underfired. So they either have too much silica or too much alumina to melt. And so, so Stahl's original research was done at cone 11, but I have recreated this chart by firing 50 tests with varying silica and alumina values at cone 6, and the patterns are generally the same. My tests also contain boron, which is required to bring the melting temperature down from cone 11 to cone 6. You can learn more about Stahl's chart and my cone 6 research here by clicking this link, which I believe takes you to my INSECA presentation from 2018, where I explain all the research that I did mapping out the Stahl chart. And so that is going to be the topic of my story time presentation for next week. So if you're interested in that, then be sure to stick around. Okay, so the white dots on the chart represent the silica and alumina levels of the matte glaze on the left and the glossy glaze on the right. So these are these recipes plotted on the Stahl chart. Also, these are the results, the fired results of these recipes. So when plotting the matte glaze, the silica level and the alumina level, it falls over here in the matte section, and then adding silica, because silica increases on the x-axis, adding silica just moves the dot over to the right. And so the glossy glaze falls right smack dab in the middle of the glossy glaze section. As you can see, the matte glaze is plotted in the matte section of the chart and the glossy glaze is plotted in the glossy section of the chart. Makes sense? In order to understand where these points come from, let's look at the recipes again, and this time with the unity molecular formula included above the recipe. So as I was trying to use my words to explain earlier, so glazy.org is a place to search for recipes and store your recipes, and it's also a place where you can convert your recipe to the unity molecular formula. Glaze calculation software, that's the word that I was looking for earlier. So what you do is you just type in your recipe with the percentages, and then it gives you the UMF, which is shown above the recipes here. So calcium matte glaze on the left. So you can see that the values are all the same. So if you go, these are the fluxes, R2O and RO, those represent the fluxes. So we got sodium, potassium, and calcium. So all those values stay the same because the only thing we changed was the silica. So we've got the alumina, 0.46 alumina stays the same. The boron stays the same. The silica in the matte version is 2.17. And then in the glossy version, it's 4.12. So, and those are molecules by UMF or moles. And so in both recipes, the alumina, Al2O3, is the same at 0.46. This makes sense because we didn't change any of the ingredients that contain alumina. We only increased the silica, which is pure SiO2. In the matte glaze, the silica is at 2.17. In the glossy glaze, the silica is at 4.12. More silica added equals a higher silica value by UMF. The highlighted UMF values are what I plotted on the stall chart. So going back to the stall chart, remember this chart only takes the silica and the alumina into account. So everything else in the glaze should remain constant in order to plot them on the same chart. And so we've got our 0.46 molecules of alumina. So this is 0.4, this is 0.5. So in between 0.4 and 0.5, we've got 0.46 alumina in both cases. And then here we have 2.17 molecules of silica. And then over here, 4.12 molecules of silica. With alumina levels being the same, the points are plotted on the same horizontal line because we are only changing the x-axis, which is the silica values. Anytime you add straight silica to a recipe, you will move horizontally to the right on the stall chart. Another thing to look at in the UMF is where it says the silica to alumina ratio. So hello, everybody. Welcome back. I don't know what's going on with Facebook, but Facebook just killed my live video in the middle of it. So I think I know where I was when it died. The screen kept going black. So hopefully you guys will catch me on this new video, and I'm going to continue, and then I'm going to edit these videos together afterwards. Okay. So hopefully you can all see and hear me again. And I'm going to start reading again, starting here. So please let me know if there are any issues, and hopefully this all works out better. Okay, so in both recipes, the alumina is the same at 0.46. This makes sense because we didn't change any of the ingredients that contain alumina. We only increased the silica, which is pure SiO2. In the matte glaze, the silica is at 2.17, And in the glossy glaze, the silica is at 4.12. More silica added equals higher SiO2. These highlighted values are what I plotted on the stall chart. So these alumina and silica values are what I plotted on the stall chart. So sorry if I'm repeating myself. I'm not sure if you guys got this last time. So here we have the stall chart. So we've got 0.46 alumina plotted on the y-axis, and then we've got 2.17 silica here, and then 4.12 silica over here. So that is how you plot the UMF onto the stall chart. And then all the other values, all the fluxes and the boron are the same. So with the alumina values being the same, the points are plotted on the same horizontal line because we are only changing the x-axis silica values. Anytime you add straight silica to a recipe, you will move horizontally to the right on the stall chart. Another thing to look at in the UMF is where it says silica to alumina ratio. So that's here, SiO2 to Al2O3. That's the silica to alumina ratio. And it's given in a numerical value that represents the number of silica molecules for every molecule of alumina in the formula. The matte glaze has a silica to alumina ratio of 4.72. This means that for every molecule of alumina in the glaze recipe, there are 4.72 molecules of silica. For the glossy glaze, the ratio is 8.98 molecules of silica for every molecule of alumina. It's this ratio, the silica to alumina ratio, that determines whether a glaze is likely to be matte or glossy. As the silica to alumina ratio goes up, the glaze will move from matte to glossy. But you can't keep adding silica forever. Adding silica also raises the melting temperature of your glaze, and eventually the glaze will have too much silica to melt and it will be underfired. So here are some of the patterns of what you'll find with the silica to alumina ratio. So if it is 5 or less, you're going to be in the matte glaze region on the stall chart. If your silica to alumina ratio is between 5 and 6, that's generally the satin glaze region. So satin is kind of in between matte and glossy. And then from 6 to 12, you're in the glossy glaze region. And then 12 or more, you're getting into the underfired region. So these are just guidelines. There are glazes that kind of fall outside of these parameters. They're not hard limits or anything, but these are like the patterns that you're generally going to see when you plot your glazes onto the stall chart. Pardon me. So will adding silica turn every matte glaze glossy? No, not every matte glaze will turn glossy with the addition of silica. As with everything in ceramics, there are some exceptions and nuances to be learned, but there's a pretty simple criteria that will tell you if this method is likely to work. All you have to do is take your matte glaze recipe and use the glaze calculation software to look at the unity molecular formula. My favorite way to do this is at glazy.org. So glazy.org is a website. It's a place where you can search for glaze recipes, and then you can catalog all of your glaze recipes with images. And then you can also look at the chemistry and the UMF of all of your glaze recipes and everybody else's glaze recipes that are on there. So you can create a free account first if you don't have one, and then enter your matte glaze recipe. Glazy will convert your recipe to the UMF and plot it on the stall chart. So this stall chart up here, Glazy will also take your formula and put a point on the chart, and it will show you which region it falls into. So if your matte glaze falls into the matte region of the stall chart, then you have what I call a stall matte glaze. And that just means that it's a matte glaze that follows these parameters that I'm describing to you. So it kind of follows the patterns and does what we expect it to. And so if your matte glaze falls in the matte region of the stall chart, then this method of adding silica to create a glossy glaze is likely to work. Now, how to adjust your stall matte glaze. And I'll talk about how to go back from a glossy glaze to a matte glaze when I'm finished here. So I'll just finish reading what I have here, and then I will answer some questions if you have them and explain a few more things. So how to adjust your stall matte glaze. All you have to do is add enough silica to move the point on the stall chart to the right and into the glossy region. You can do this by making a copy of your matte glaze in glazy.org, and then you use the plus button. So when you add a recipe, there are little plus and minus buttons, so you can like nudge the material values up. And so you can just go plus, plus, plus on the silica, and you'll watch the dot on the stall chart move to the right. And so you can increase the silica until the dot on the stall chart falls into that glossy glaze region. And voila, you've reformulated your matte glaze to be a glossy glaze. And then of course you have to mix it up and test it in the kiln to make sure, but generally this is going to work. If you want your matte glaze to be satin or only slightly glossy, then just add a small amount of silica. This will move the dot only slightly to the right on the stall chart. Typically, a silica to alumina ratio between 5 and 6 will give you a satin glaze. If it's too matte, add some silica. If it's too glossy, remove some silica. Testing is always required to get the exact result that you're looking for. If you want it to be glossy, aim for a silica to alumina ratio of between 7 and 10. And that should pretty much guarantee that it's going to fall into that glossy region. Once your silica to alumina ratio approaches 12, then your glaze is at risk of becoming underfired. So what if your glaze isn't a stall matte glaze? So if you enter your matte glaze into glazy.org and you find that it doesn't fall within the matte region of stall, then it's not what I would call a stall matte glaze, and adding silica might not make it glossy. So there are other reasons why your glaze might be matte, and it might not be based on the silica to alumina ratio, in which case this method of adding silica to move that point on the stall chart from the matte region to the glossy region isn't necessarily going to work. Some glazes are matte because they contain titanium, which crystallizes during the cooling cycle. Adding silica to a titanium matte glaze won't necessarily make it glossy, and that's because the glaze still contains titanium. And it's the titanium that is crystallizing during the cooling cycle that is making your glaze matte, and it's not based on the silica to alumina ratio. So adding silica might, it just depends on how much titanium is in the recipe as well as where it falls on the stall chart, and it never hurts to test it. Other glazes are matte because they're underfired. An underfired glaze appears matte because it hasn't melted into glass yet. Adding silica to an underfired glaze definitely won't make it glossy because adding silica raises the melting temperature. If your matte glaze falls in the glossy region of the stall chart and it does not contain titanium, there's a pretty good chance that your glaze is underfired, and that's why it appears matte. So look at the images below. The matte glazes are in the first photo. And then you can see how the glazes are slightly runny. So there's like little drips coming down on the side here. And then the glossy glazes in the second photo aren't runny at all. This shows how increasing silica raises the melting temperature of a glaze. So I just wanted to, I received a question from Phyllis who said, I've made glazes glossier by raising the cone from a 5 to a 6. And so if your matte glaze goes glossy when you increase the temperature, then that's generally an indication that when your glaze was matte, it was slightly under fired. And so raising the temperature helps to get everything melted properly. And so it's actually a glossy glaze that's being under fired, and that's why it appears matte. So the question is, I've made glazes glossier by raising the cone from 5 to 6 or by soaking it at the last firing cycle for 30 minutes. Does it make sense to get a more matte surface to do the reverse by lowering the cone and making the cycle faster, so having a quicker firing cycle? Yes, so I don't recommend lowering your firing temperature in order to keep that glossy glaze matte. So if you have a glaze that is matte because it's under fired, generally, until a glaze is properly melted, all those particles aren't really fused together properly. And so that's going to affect the durability of the glaze over time. A glaze that hasn't properly melted is going to be more susceptible to leaching and breaking down. So I don't recommend lowering your firing temperature in order to create a matte glaze if you're making functional wares. So if you're making anything that's going to go in the dishwasher or be eaten off of, then I wouldn't recommend lowering your firing temperature. For one thing, your clay, you want your clay to be fired to its maturing temperature so that your clay is vitrified. If you lower your firing temperature, then your clay becomes a little more porous, which also isn't great for functional pottery. So if you're making functional pots, I don't recommend using a matte glaze that gets glossier when it's fired to a hotter temperature, because that just means that it's under fired. But if you're making decorative ware or sculptural ware, something that isn't going to be put in the dishwasher and it isn't going to be eaten off of, then you can basically do whatever you want, because these factors really only matter for surfaces that are going to be coming into contact with food and with, with hot water and soap from the dishwasher, which can start to break down an unvitrified, like an underfired glaze. And then if your clay body is underfired as well and you're putting it into the dishwasher, when your clay body is porous, then it absorbs moisture, it can hold bacteria and that sort of things and be generally a little bit harder to clean. So so I don't recommend lowering your firing temperature for functional pots. Andrew says, I use a low fire clay and glaze fire to cone 04. Would these rules apply to my glazes as well? Yes, definitely. So these patterns work at any temperature. So the general guidelines is you just have to, as long as your matte glaze. So when you have any glaze is going to have a silica levels and alumina levels and can be plotted on this chart. So the fluxes are constant, the boron is constant. Generally, with lower fire glazes, you're going to have higher amounts of boron, but then the silica and alumina values tend to match glaze recipes from cone 6, cone 10. It's just the boron level that changes. That is what increases or lowers the melting temperature. So it increases the melting. So as long as if you have a low fire glaze and it falls in the matte region of stall, and then you add silica to move over to the right, generally that's going to turn your matte glaze into a glossy glaze. Okay, so where was I? Okay, I reached the end of the article. So always fire test tiles to be sure that your new glaze looks the way you want it to before making a large batch. And then fire some test pots before glazing all of your work. A really informative test would be to take a matte glaze and incrementally add silica, moving across the stall chart, dipping a test tile after each addition. So then you'll see a progression from matte to glossy, and you can pick your favorite. So in that example, so I would recommend to get the most information and to really understand what's going on here. So you have your matte glaze in the matte region. I would add a little bit of silica just to nudge it over a little bit. And then I would dip a test tile. And then I would add a little bit more silica. I would mix it up, dip another test tile, and do a test kind of moving along the x-axis of stall. Just all you're doing is adding a little bit of silica. And then you're going to get a test tile for all of these points over here. And then you can say, oh, I really like the glaze best when it's, you know, the silica to alumina ratio is at 6:1. It's kind of satin. I like it there. Or you might like it super glossy. And then as you keep moving to the right, it's going to go through like the most glossy phase. And then the glossiness is kind of going to go dulled down as the silica amount gets higher. So you'll have the range, and then you can pick the result that you like the best, and then you will know how to make that glaze recipe. Sarah says, hi, Sue. What can you add to bring the temperature of the glaze down if you want it to be glossy, but not fire above cone 6? I think you've just answered my question. Yeah, so if you want to bring the temperature down, generally adding a little bit of boron is going to lower the firing temperature. Now, it's hard to just add boron without adding a bunch of other things as well, because we source our boron from Fritz and Gersley borate generally, which also contain calcium and silica and alumina and all the other things. But if you were to recreate your glaze recipe where the only factor is an increased boron level, then that would bring your melting temperature down. And you, as long as you're not like increasing it by a whole bunch, generally the glaze will behave the same. Like the appearance should be similar to what you started with. It'll just melt at a slightly lower temperature. Now, Andrew has another question. Andrew says, all my low fire glazes are glossy apart from a crawl with magnesium carbonate. I'm excited to try reducing the silica to get some mattes. If not underfired at the glaze stage, these new matte glazes would be just as food safe as their glossy counterparts. Yes, so that's the thing, is like when you have a matte glaze that falls into the matte region of the stall chart, that's like the true matte glaze, meaning that it's properly melted and it's not under fired. And so, the durability, food safety, everything would be the same as the glossy version of that glaze, as long as it's in the matte region. If your glaze is under fired, then that's where you start losing the durability and possibly food safety could come into play there. So I want to talk about how to convert a glossy glaze to a matte glaze. And so you can do the same thing by taking your glossy glaze, plotting it, enter the recipe into Glazy, and then find out where it falls on the stall chart. And the criteria, the thing is you need to have silica as an ingredient in your glossy glaze in order to be able to remove it. And as you remove silica, you're going to move to the left on the x-axis and back towards the matte region. So the problem with this is because we get silica in our glaze recipes from lots of different materials. So it's not always silica as an ingredient. Feldspars contain silica, Fritz contains silica, wollastonite and talc both contain silica. So silica kind of comes into our clay contains silica. Silica is provided to our glaze recipe from all these different sources. And so it's possible that your glossy glaze recipe doesn't have enough silica just as a standalone material in order to remove enough of it to move it into that matte region. So that's just something that you're going to have to just plot into the glaze calculation software, see where it falls, and then take out all the silica and see how far your glaze moves back towards the matte region. And if it makes it all the way to the matte region, then you're good to go. If it doesn't, it's possible with glaze calculation software that you could do some material substitutions in order to reduce the amount of silica further. But that's going to take a little more chemistry, which is definitely possible to do on glazy.org. And so if anyone has a recipe that is a glossy recipe and they're curious whether they could turn it into a matte glaze, feel free to just post that into the Facebook group. It would be really helpful if you enter your glaze into glazy.org first and save it, and then post a link to the recipe so that those of us that are going to help you can just click the link and see where it falls on the stall chart, and then we can help you determine whether we could remove some silica to turn it into a matte glaze, or if some reformulation needs to happen in order to remove the silica, which can happen with material substitutions, but it does get a little more complicated. So hopefully that answers your questions. I'm happy to take any more questions that you might have right now. Sorry about the technology problems earlier. What I'm going to do is I'm going to take the first video and the second video, edit them together and create the full video, and then I'll post that to the group, as well as on my website and Facebook page and Instagram and YouTube and all the places. So you'll be able to go back and watch this again, and maybe follow along as you're analyzing your glaze recipes and seeing how they move around the stall chart. So I just want to make sure there's no unanswered questions. Okay, looks like I got to everyone. So thank you all for joining me and for being patient with my tech issues. And then next week for story time, I'm going to do I did an NCECA presentation in 2018 called Understanding Cone 6, where I plotted, I made a recipe for all the points on the stall chart. I did 2 versions of the map. So I did a different flux ratio. We didn't talk about flux ratios today, but I did a different flux ratio for each map, and I fired them all to cone 6. And then I present my results and I talk about the crazing region and the underfired region and moving from matte to glossy and all of that. So I'm going to give that presentation kind of as a story time so that I can answer your questions as we go, just like we did today. So stay tuned for that. More chemistry coming to you guys. And I hope you all have a great day, and I'll see you next time for story time.